So now I request Professor Vineet, Assistant Professor of Mechanical Engineering Department, Adi Shankara Deemed University, to introduce our chief guest to the gathering. Vineet sir, please.
Good evening, everyone. I am Mr. B.C. Vineet, Assistant Professor in the Department of Mechanical Engineering at Rajaganesan deemed to be University, Guru, Andhra Pradesh. We are privileged to welcome Mr. G. Rajaganesan, a distinguished professional in the field of solar PVs, green hydrogen, and electrical vehicle infrastructure as the resource person for this ATAL FDP. Mr. Rajaganesan holds a bachelor's degree in electrical and electronics engineering from Anna University and has accumulated over 12 years of experience in renewable energy systems. He began his career at a BHEL corporate R&D center and has since established himself as solar technocrat, bridging the gaps between government, industries, and academia. Currently, Currently, he serves as the Director, Technical Operations at Vatio Energy India Private Limited and as the Chief Technical Officer at Tamil Nadu Advanced Technical Training Institute. He has played a pivotal role in setting solar PV power plants, hybrid systems, EV charging infrastructure, and green hydrogen projects across India. He is also a certified master trainer in solar PV and green hydrogen under the Skill Council of Green Jobs and National Institute of Solar Energy. His academic and professional contributions include developing curricula and training content for national level programs, guiding numerous research and consultancy projects, and authoring the widely referred Handbook for Solar Photovoltaic Technologies. He has delivered over 45 invited lectures at reputed organizations such as ISRO, NPC, REC, Anna University, and other leading infrastructures. Internationally, Mr. Rajaganesan has represented India in Intersolar and CIPB conferences in China and has been an invited delegate at prestigious institutions like Solar Energy Research Institutions of Singapore, Nanyang Technological University, Singapore. As the President of National Association for Renewable Energy and Research and a member of several university advisory boards, he continues to contribute actively to policy making, training, and capacity building in renewable energy. With his versatile expertise in solar energy systems, green hydrogen, EV infrastructure, and renewable energy policies, Mr. Rajaganesan stands as a true resource person to guide, inspire, and empower the participants of this FDP. On behalf of the organizers and all the participants, I extend a very warm welcome to you, sir. With these words, I now hand over the session to our esteemed resource person, Mr. Rajaganesan. Thank you, sir.
Thank you very much, Vineet sir, for giving a welcome note. And also thank you, Manoj sir, for organizing this program. And hearty congratulations to Adi Shankara and also ATAL for sponsoring this program. And so I feel always that these kind of programs really make a kind of a bridge between different peoples gathering in a single place for a common cause of gathering knowledge, discussing technology, and taking the research and publications all to the next level. As we all know that this industry, solar and electric vehicle, green hydrogen, battery energy storage systems, all these things are picking up in a very faster pace compared to the last 15 years. So as per the latest report, India's target by 2030 is to achieve 500 gigawatt through renewables, okay, by producing the clean energy. Out of that, in the last 15 years of journey, we have achieved only 246 gigawatt. So whatever we have achieved in the last 15 years, that needs to be addressed within 5 years. to achieve the target. Okay, so that is one thing which shows the kind of enormous potential which is prevailing in this market. And now, if you talk about the other driving factors for solar market, since I'm from a solar background, my business verticals flows further into the auxiliary veins like EV charging, green hydrogen, and energy audit and energy monitoring, all these verticals. Because the EV is picking up, and if you see 10 cars, one or two cars is now EV. So that kind of rapid growth has happened, and we came to know like the kind of EV sales is going like anything well compared to the IC engine in some cases. So the acceptance of EV and the kind of reliability what they witnessed in the last 5 years after the first EV came into the market is giving a confidence about people to go for EV, and especially people with 2 or more cars and looking to buy one car for city commutation for daily usage. 100% they can close the eyes and go and buy that, no doubt about it. Because if you compare the kind of cost per kilometer with respect to the IC engines and EV, there'll be a huge difference. If you take an IC engine, it falls somewhere between 6 rupees to 8 rupees per kilometer. Whereas if you see the EV, it falls around 1.2 to 1.5 rupees per kilometer. So there is a big difference. So if someone drives a car at least minimum 30,000 kilometers per year, you can definitely have to go for EV, because your fuel cost is going to be completely slashed down to the extent of 80%. And provided if you go with solar to make your electricity free for charging, it will be much more a better option choice for you, because solar will generate the units for charging. So literally, if someone wants to drive a car for 1,500 kilometers a month, they can comfortably go for 2 kilowatt system, and the government is giving subsidy also for solar. Up to 3 kilowatt, they are giving 78,000 subsidy. So if you calculate that, for a 3 kilowatt system, you can install in 1.2 lakhs, and you just add it with the 1.2 lakhs installing a 3 kilowatt system. That is going to support for 3,000 to 3,500 kilometers free every month. That's a very big thing for anybody who really puts fuel in the car. So there is a case study in one of my customer place where we have installed 6.5 kilowatt of solar, and that it eventually saved almost 14,000 rupees electricity bill. Along with, he was supposed to put 15,000 rupees fuel cost, petrol for his car, that now become completely zero, because solar, they are putting charge in the home, and they have a solar net metering in their home. So solar plants have the excess energy, and that is get adjusted while charging the car. So this is a win-win situation. So by just investing that amount, you could able to see the savings in 2 points. One is reduced electricity bill. Other is reduced complete elimination of the gasolines, petrol or diesel, whatever it is. So this kind of approach really makes a kind of a good growth in switching the path towards sustainable approach for the future stability. And also it's kind of a commitment I feel everybody should take somewhere to support the climate change. And we need to try to reduce the kind of carbon footprint as much as possible from our own ways and means of the lifestyle. So before going into a formal kind of presentation, what I have to show you, I just want to have some quick questions from the audience, like what is the kind of the exposure you have with respect to the solar and EV, and what you really look forward to ask questions from me in this session. If I can be able to get some few questions or some insights about this audience front, it will be much more easier for me to take the session in that angle. So looking forward some inputs from you. So you can just unmute and ask the questions or tell me what's your expectations.
Good evening, sir.
Yeah, good evening.
Sir, this is Parani.
Yeah, sir.
What is meant by carbon footprint, sir?
So footprint means when we walk, we leave something on the ground. Correct. That is
Yes, sir.
what we
Yes, sir.
use as a footprint. Similarly, when you drive a car on the road, if you
Okay.
release the smoke that has carbon, suspended carbon, into the
Okay.
atmosphere, that is what logically they mean it as carbon footprint. So if you drive a car, if it emits a smoke, if it comes on the road, you are literally emitting the carbon into the carbon on the road. So that is what they refer as footprint, carbon footprint. Got it? Hello.
Any other questions from the participant side? Sir, you can continue, sir.
Okay, 76 people, only one question. Okay, Mani Sagan is asking. You can even chat also. I can read your questions and answer you. So Mani Sagan is asking solar PV panel based project to do research work. Do you want to do the research work on the solar PV side, or what is your question really about? If you really want to do the research work on the PV panel side, yes, definitely there is a huge scope, but the kind of research you need to do make some phenomenal changes, then the kind of laboratory which is required to do on the cell level, crystal level, the changes, we need to really explore the research possibility, how much it is feasible in India. So mostly these kind of researches are happening in Singapore, Japan, China, and mainly most of the European countries. So they are very keen on developing the technology. More or less, India is just only manufacturing and implementing it. We can see very less kind of PV cell level or even module level development or new researchers came in India. Selection of material front is definitely, it's a bigger area to concentrate on that deals with material science. There are always there are replacement and mixture and composition of doping of different materials for different purpose. One is for stability, other is for better conductivity, other is for better thermal resistance and lower thermal coefficient factors. Like that, there are many factors which influence the selection of material. But for a country like India, and most of the places are tropical, and the temperature is really moderate or even high in many places, especially in South India, if you see. So it's better to go with more about crystalline technology, whereas more the European countries are inclined towards thin film, CIGS, CDTE, and all. Okay, so every technology has their own pros and cons. It's all about what is the kind of cost of the module, what is the cost of energy during the life cycle of the module, and how much pollution happened during the manufacturing of the module, and what is the levelized cost of energy that we can able to acquire from the module when it gets installed. So these factors decide the selection of products, technology, basically. So if you ask me for a state like Tamil Nadu, I would say crystalline technology performs better. If you go to a country like Europe, if you ask, I can tell like thin film technology or CDT or CAGS works better because it can even support during the diffuse light conditions. So it's all based on the nature of site. So that's very important. And Mr. Premnath is asking, sir, presentation slide is not visible. I have not even presented the slide. I just initiating the conversation with the audience to understand better. My presentation is going to start in next 10 minutes. So we have time till 7:30. So I will start by 6:30 and we will have 1 hour to discuss on the slide. So any other questions? Okay, Ritu Tomar is asking questions. Sir, how much possibility is there that we can save Earth with this environmental full of greenhouse gases in 2025? It is showing its disastrous effect everywhere. Exactly. From today, if you start completely stopping all the exposure of greenhouse gases into the environment, it will take at least 30 years to at least 25 to 30 years to get it saturated to a point, which means not depleting further. Then recovering it is again a bigger question. So if you want to stop this today, it will take 25 years to get it stopped from the ozone layer point of view. Okay. So that is why government is very keenly working on, every government is having a 20 years target, 15 years target, 25 years target, thinking that if today we take an action, at least the next generation will be not protected, at least avoided from hazards. Okay, for further vulnerability. But whatever we created, we destroyed, that effect is going to be there always because we already did it. Okay, but we can avoid the further depletion. That is what we are trying to do now by various means and ways of taking the measures, by installing solar, by implementing green hydrogen, by adopting electric vehicles on road. Again, there is a myth and reality behind switching to the EV also. Unless you charge the electric vehicle through a green energy, which is produced from a carbon-free source, it doesn't make any impact of driving a car. Because if you drive a car, of course, the energy needs to travel from a power plant to the home, and the home needs to charge the car. So there is always a transmission and distribution losses, which is going on one side. And any which way, 60% of the power is coming from coal, thermal, the major resource. If you take the annual average, 50% at least. So 50% of the carbon is only reduced. Balance 50% you are emitting into the atmosphere. Okay, unless the energy is produced completely from the green, even though driving a car on road, a EV car on road, is not really a clean transportation. That's a conclusion. So to conclude the Ritu Tomar question, we need to take actions today for a better tomorrow, but the tomorrow is at least 25 years. So the question from Dr. P. Marshall Arokedas: which solar panel is best, monoPERC, TOPCon, or IBC? As of now, TOPCon is performing better. So it is in most of the practical cases where we installed, we can able to see it is touching 7 units per kilowatt per day. So that's a peak. 7.2 up to it went. So that's one good thing. TOPCon bifacial it is. N-type TOPCon. Okay. Then Palani Chinna is asking, what is the efficiency improvement after incorporating nanotechnology? Implementing nanotechnology where you are talking about cell or module or component, what are you really trying to mention? So Dr. P. Marshall Arokedas is asking, which angle is best angle to place solar panel? So when you are in the northern hemisphere, you should face towards south direction. When you are in the southern hemisphere, you should face towards north direction. And the angle of tilt should be equal to the latitude of your location. Okay. So Palani Chinna in PV. Okay, in PV cell, if you talk about the nanotechnology, there are different areas we can talk about, right? From the selection of material, the quality of ingots, slicing of wafer, texturing of wafer, deposition layers over the wafer for different layers, creating multiple junctions over the cell. All this is done through the nanotechnology process only. So everything matters. I cannot simply tell. Definitely, nanotechnology really helps in various means and ways. So, Mr. Devraj, they kindly give the comparison in terms of EV and fueled vehicles in terms of cost. Yeah, as I already told, if you drive a EV car, it will cost you 1.5 rupees per kilometer. If you the same size car, if you drive through petrol, it will cost you 8.5 rupees per kilometer. And Dr. B. Marshall Arokeda was asking how to improve solar panel efficiency. Solar panel efficiency can be improved by means of adopting different practices. One is changing the material of the cell. Other is implementing some layers, creating some anti-reflective textures, changing the nature of glass to increase more absorption of photons coming from the light, and reducing the space between the cells, reducing the reflection losses from the bus bars, and optimizing the better thermal coefficient factor so that the thermal loss will be less, and reducing the current possibility so that the I square R loss will be less. So there are, and putting the bifacial technology approach so that production happens from both the sides. So there are multiple ways to improve the panel efficiency. So we cannot simply tell only change this, you will get the better output. Everywhere there is a possibility to improve the efficiency. Okay, so I think we got a decent questions. Any other questions? All right. So to take it further, how many of you have installed solar?
Material. What type
Hello?
of material? Another question is there, sir. Chat box.
1 minute.
Sir, please, sir, please.
Yeah. What is the type of? It's an N-type top corner. It is a silica only. The wafer is made up of silica ingot. Silica is sliced into a micro wafer, and that is coated with phosphorus boron, and the top layer is an N-type. Okay.
Yes, sir, you can go ahead, sir.
Yeah. What is the best height to mount the bifacial solar panel? At least you should have 4 feet height, minimum height, to mount a bifacial. But having anything between 4 to 7 feet is really good. If you go more than that, then it doesn't make any sense because the light gets scattered much more. So ideally 4 to 5 feet is the ideal height. You go for a bifacial. Any other questions? One more question. How to protect solar panel from cyclone? You have to do the proper installation of solar panels with the proper structures with proper concrete ballast anchored on the roof. You have to put a perfect stability arrangement and give some stiffeners or bracings so that even 150, 180 kilometer wind speed come, it should not disturb the stability of the structure. So we have even our systems have even seen 150 kilometer per hour through the cyclones, through Varda, Gaja, all the cyclones we faced. Our installations have been there in the places where cyclone crossed, but nothing happened because MNR is clearly mandated. Whatever the structure you are doing, you should at least withstand 150 to 180 kilometer wind speed from the considering the wind is from the backside of the module. Okay, so you need to properly design the structure, get it tested or simulated from a model where your stress, strain, and everything is analyzed, and you have to use the proper fastness and see what is the kind of height you are putting and what are the kind of counter effects you are making to increase the better stability. So once you do all these things, even 150 kilometer wind speed comes, it will not affect your module. So it's all about proper engineering and proper installation practice. So Vishnu is asking what are the percentage of subsidy for solar and any special subsidy for women's. In India, there is no special subsidy for women's. Subsidy is capped at 78,000 rupees up to 3 kilowatt, 30,000 for 1 kilowatt, 60,000 for 2 kilowatt, and 78,000 for 3 kilowatt. People installing more than any kilowatt, they are eligible only to claim 78,000. Abhay Bentakar is asking, can we compare hydrogen energy fuel cell systems and solar energy systems for EVs? Which one is more beneficial in the future, or both will? Okay, can we compare hydrogen energy fuel cell systems and solar energy systems for EV? Which one is more beneficial in the future, or both will work? I'm working on hydrogen energy system. Very good. Okay. So hydrogen energy, if you see, the green hydrogen is what you're talking, or you're talking about the general hydrogen fuel cells. If you talk about utilizing the hydrogen for fuel cells for an EV application, definitely it should be a green hydrogen. And if you see the cost of green hydrogen, 70% of the cost for generation of electricity from the fuel cells is going for the power which is being utilized during the electrolysis process. Okay, by separating this thing, generation of hydrogen from water. So if that power is being completely supported by solar, and in, let's say if they are taking the break even in 4 years, post that the cost of production of hydrogen will become 70% less compared to the present price. In that moment, I mean, after the the peak first 3 to 4 years, it's happened in the same every industry. For solar also, we have cases where the PPA has been signed for 25 rupees, 28 rupees per unit for solar. Now the cost per unit for large scale utility plants are 2.4 rupees, 2.5 rupees. So imagine 10x cost reduction happened in the cost of energy. What it's been produced before 15 years, what it is now. It is applicable for any industry which gets evolved in the period of time. So in hydrogen also, after 3 to 5 years, we can see a better competitive solution from green hydrogen business sector also. And mostly within 8 years, green hydrogen, the hydrogen fuel cells technology is going to be one of the most predominant market player in the the power sector.
Sir, can we go for the presentation so that everyone can benefit, sir?
Okay.
See, some few people are only having chatting. Almost half an hour. We have the Q&A at the end of the session, sir. All the 90 days. So participants, put your questions in the chat box. End of the session, our guest will address all your queries. Thank you.
So shall we proceed?
Yes, sir. We can, sir.
Yeah. So the transportation sector causes. Before that, I just brief about the title of this session. So this topic is about integration of solar power in EV charging infrastructure and its economics. So we are going to talk about how we can integrate the solar power, the solar rooftop systems, or the commercial solar rooftops into integrated with a domestic or a commercial or a fleet operating EV charging infrastructure, how it is going to support that business model and how it is going to be a more viable option for the contractors. So before getting into why EV is a booming market and why solar is also important to be executed along with EV. So we'll see first. So the transport sector causes almost 40 to 80% of air pollution in most of the cities. So decarbonizing the transport sector by deploying renewable energy is a vital need of the hour. Okay. And the ultimate aim is to reduce the carbon footprints into the atmosphere. So that's the whole idea about it. Now, solar powered EV charging station reduces the carbon footprint and also it paves the way for the green mobility. No doubt about it. And India's EV market is growing by 90% every year, and it's going to touch almost $150 billion market by 2030. So now every person inside the city, if they're really looking to buy a car, they are considering to buy an electric bike. They are considering to buy an electric car. So that shift is really an great shift we are seeing in the market. And EV sector have seen a massive growth in the last 5 years, right from 2021 to the 2025. The last 5 years, so we have seen a very big transition, right from the 1.3% to almost 8%, and it is keep on increasing. So the EV future in India, how it's going to be. So the India's shift is mainly towards connecting the better mobility across the country. And the bigger uncertainty of why not going to EV is the charging stations and charging infrastructures. There is no uncertainty about how the charger is going to work because everybody knows what is this EV car, how it operates. And EV charger is nothing but a device, how you use a mobile charger to charge your device. Similarly, there is a charger which is going to take the power from the grid and it is going to give it the either a AC or a rectified DC to the vehicle. So there should be a safety mechanism, there should be a monitoring mechanism, there should be a protocol controlling factor to communicate between the vehicle and the grid. So there should be one device which should act as an intermediator between the grid and the device. So that is the EV charger. So either the EV charger can be an AC charger or it can be a DC charger. If it is an AC charger, it is going to send the direct AC power to the vehicle. If it is a DC charger, it is going to convert the AC supply, which is coming from the grid, into a DC, and that DC is going to go directly into a vehicle. Okay, so we have the standards for connectors. In India, we are using CCS2 as per the Bharat standards. So all the cars coming with similar charger points so that we have a common charging approach. And as per the reports, it says that India needs about 4 lakh charging stations to be met for 2 million EV cars that is going to be potentially on the roads by 2026. If you really see we have 4 lakh charging stations on road, definitely not. We are having only 40,000 charging stations as of now, the commercial fast charging stations. So the idea is to have at least on the highway 25 kilometer one charger. Inside the city, at least for every 2 square kilometer to 4 square kilometer, we should have chargers. So the more deployment of EV chargers on road, on inside the cities, inside the residential area, inside the common areas of the apartments, is going to increase the confidence and also reduce the kind of uncertainty about where to charge a car. Can I get an electricity supply if I go and charge a car? And if this charger is not going to work, how I'm going to charge the car with some other charger? How I can able to find that charger is available? How I can know that the charger is free to charge if I go there? If already some car is charging, I need to wait. So there are n number of uncertainties which is there in the minds of people who look forward to buy a car. So addressing those points to the various technology and solutions is the bigger market. That's where even before and all, parking is a very common thing. You go, if it is available, you park. Now there are many startup, many companies, the Park Plus and all, they come up with a solution. They organize it, make it as a structured way, connected it with the fast tag, and they are giving another RFID tag. It's become more, structured. So if a car is entered, it clearly shows it's going to be parked in their area and the parking is full. And it clearly shows how many cars are inside, how many parking slots are open, how much is full, how much is empty. So it makes the process easy. Similarly, there are systems and mechanism which is already adopted in charging management systems. The charging management systems and the portal of EV charging charger network clearly tells about how to charge, where to charge, when to charge, what is the nature of the charger, whether it is an AC charger, whether it is a DC charger, and what is the health of the charger, and whether it is active now, whether it is available now, what is the cost of charging. Everything is clear, transparent, and it is available in the apps of the chargers and also the CMS, charging management solution providers. So how to make it happen, the solar EV charging infrastructure? So before getting into that, we need to know the different kind of vehicles which is there already in the market. If you see the vehicle segment, there is two-wheeler segment, three-wheeler segments, cars, the bigger SUVs, and the commercial vehicles like bus, trucks, and all. So the minimum two-wheeler, let's say the cycle kind of thing, starts from 1.2 to 3.3 kilowatt hour battery, and the voltage is about 48 to 72 volt, and it keeps on increasing from 8 kilowatt hour, 21 kilowatt hour to 80 kilowatt hour battery. So all the SUV cars now, you are seeing the Harrier and B6E, B9E from Mahindra, all the big cars now, they are having almost the 70 kilowatt hour, 68 kilowatt hour, 75 kilowatt hour battery. So that's the kind of maximum battery capacity which is available in the market, and the kind of battery voltage is also there for that. So whenever we are going with the high voltage DC supply, then the vulnerability of the electrical shocks, electrical safety, and the safety practices needs to be considered while designing the system, plays an important role. We are very comfortable and conversant and convenient with IC engines for so many decades, but now this decade we are really shifting to an alternate technology, which is really economic in terms of the fuel cost, but also there is a big question about what is the kind of safety we are having on the device front. Okay, of course, in the history of 5 years of electric vehicles into the commercial market, we have seen some kind of accidents, problems, faults on the EV front, but the nature of fault, the reason of the fault are totally different from what the general perspective from the customer front. So people, there was some kind of a misconception happen in the early stages that lithium battery will get burned, EV batteries will get bust. Okay, but how many times it happened, where it happened, what is the reason for it? If you really go and research, there is definitely a solid reason, not on the problem of product reliability front. Okay, of course, if you go with a local market product or very imported cheap batteries from Chinese market or Korean market, you have higher probability of facing the problem, seeing the lower efficiency in the long run. Of course, you know that every battery is having a factor of the derating factor. Like solar panels, how it gets the performance reduction year on year due to the continuous usage. It can face up to a maximum of 0.7 to 1% efficiency drop every year if you see the solar panels. Similarly, there is a efficiency drop which we are going to see in the batteries also. So what every manufacturer claims is in the next 5 years to 10 years, the battery will deliver at least 80% of its capacity. Okay. So that's why most of the car manufacturers, they usually give 10 years warranty. And many people now giving a lifetime warranty. So the lifetime warranty means if you buy that car and you are not selling that car, if you are the only owner you are using since the purchase of the car, then the battery is covered under warranty. In case if you are going to sell the car and it only covers 10 years, post that whatever problem happen, it comes at a cost. So it again varies from manufacturer to manufacturer. Some people even sell the car without battery, and you can even rent the battery like a bus model, battery as a service. So that is also available from MG and all. So it varies. Every manufacturer comes with own business models, and you need to explore which one fits for your own requirement. So the types of AV charging, if you see, we can classify as AC charging and DC charging widely. So AC charging starts from 2 kilowatt to 22 kilowatt, whereas DC charging starts from 2 kilowatt to 200 kilowatt plus. Even you can have 240 kilowatt charges. So in AC, if you see right from the 3-pin to the type 1 and type 2, and DC if you see CHAdeMO, combo and type 2. So in India, we are using type 2 charger only for AC and DC charging. And that is widely supported for many of the cars which is coming into the market as per the Bharat standards. So the slide what you're seeing is a typical representation of the EV car and how it's get connected. If you see the left side with orange color, it denotes the AC charging mode, and the right side green is clearly showing the DC charging mode. So basically the main component, the core component inside the car is the battery, and the battery is a DC operated device. Either to charge the battery you need a DC source, and the kind of power you can take from the battery is also DC. So it's basically a DC device. And if you want to charge that battery, you have two options. Either you can directly charge with the DC power, or you have to convert your existing AC into DC. That's where the onboard charger comes into the place. So you can see here the onboard charger, the orange box. So that the function of onboard charger is to convert the AC supply which is coming from the grid through the charger and get it convert into a DC. And that DC is a regulated conditioned DC according to the battery voltage. And also the battery onboard charger should eventually have to handshake with the battery BMS, that is a battery management system. So understanding the battery nature and the battery behavior, the onboard charger should work in parallel with the battery, either to full the battery, charge the battery, deciding in what mode the battery needs to be charged, what voltage needs to be given, what is the kind of current limitation needs to happen. In case if the battery temperature have touched the certain point, then the charging needs to be stopped. So all the factors will be decided by the onboard charger. The main aim or objective of the onboard charger is to comfortably, safely charge the car, charge the battery. And similarly, if you see on the right side is the DC charger. The DC charger will directly charge the battery through the DC supply, which is coming from the fast DC charger. So mostly in AC, it's kind of a slow charger. The DC or fast charger, we can call it as rapid chargers. Because since it's a DC to DC, you can straight away charge the car quickly, and it can support up to, if you see the fastest charging car according to the Indian is 140 kilowatt charger. So which means for the car from 20% to 85%, you can charge in the matter of 15 minutes. Okay. So with that 15 minutes charge, if you can able to drive for 450 kilometers, it's really a good thing. So 15 minutes is just a time you take to have a refreshment, a coffee. So in that time of taking the coffee, if your car can able to run 400 kilometers, the technology is really, satisfying and achieved. So the point of that 400 kilometers in one single charge in a matter of 15 to 20 minutes is already achieved. It's already achieved by vehicles like Mahindra B60, Harrier and all. But what is the cost? So buying a car for 28 lakhs, 30 lakhs, it's really a question for middle class segment. So most of the people can able to afford up to the maximum of 15 to 20 lakhs. But anything exceeds 20 lakhs, people really have a second thought about, is it really worth to have an EV for spending 25 lakhs, 30 lakhs? If I put another 5 lakh, 10 lakh, I can even buy a better SUV. I can even buy a premium car. So it's all about what is your priority and what is your selection criteria. Right. Now coming into the EVC power ratings. So the normal power charging and high power charging we can classify based on the power levels. So less than 7 kilowatt are slow chargers. So whatever the domestic charging happens in that, either it's a 3.3 kilowatt or 7.5 kilowatt. So the normal AC charging, it happened either in the AC and DC based on the vehicle selections. Right from 7 kilowatt to 13 kilowatt and 11 kilowatt and 22 kilowatt. It's also possible in AC and DC charging. So mostly AC charging gets over with 25 kilowatt, 22 kilowatt capacity. Above 22 kilowatt, whatever is there in the market, it's all DC. And you can have a charger up to 200 240 kilowatt chargers. You have multiple guns also in the vehicles. So in case if it is a 120 kilowatt, if the vehicle needs a 240 kilowatt charging, and it has two guns points where you can connect two 120 kilowatt chargers on the same vehicle, it can able to charge it. So that kind of facilities are also there. So all the big buses and commercial vehicles with solar, with EV charging, if you see, it has two ports because to handle the current capacity. So if you go for the much more high capacity, the charging points, the safety is also one of the critical component. So having multiple guns will reduce the effect of current and safety. So the charging infrastructure can be set up in different ways and means. If you see right from the private charging, there are different models, business models, and also the implementation models. So if you see the private charging thing, that is nothing but implementing an EV charger on your own place facility for your own cars or for a personal purpose. So it can be implemented in places like in individual homes, dedicated parking, spots in an apartment or office. That is for your own purpose. So most of the ownership belongs to the individual EV owners, EV flat owners and operators. And that is called self-operated. So you are the owner, you are operating for your own purpose. So CPO means charge point operator. Some places where the CPO, let's say you see ATAL. ATAL is the bike manufacturer. Ola is a bike manufacturer. And if ATAL bike needs to be sold, then they need to ensure that ATAL chargers are available in all the major places. So that is nothing but the charge point operator. So ATAL is a charge point operator, installing chargers in all the main places, creating a confidence that yes, I can take the ATAL bike anywhere so that I have already a charger, so I can put the charging there. So that's a business model. Then there is a semi-public charging model. So semi-public charging means where it is supported by the public as well as the individual. So that's kind of a shared charging for the restricted set of EV users. Let's say you have an apartment complex and where you have multiple owners, and you have an office complex where you have multiple owners, or gated communities or shopping malls or hospitals, universities or government buildings where we have multiple users, but so nobody can able to put money from their own single max pocket. So in such cases, it's kind of a semi-public charging approach. So where either a OEM will come and install and collect the thing, or it can be a CPO. So OEM is like, I'm a manufacturer, I'm a company, what here, so I'm going to manufacture the charger. I'm going to install the charger, but I'm not going to charge them the actual cost of the charger during the installation. Instead of that, I will charge the cost per unit whenever people put a charge. It's like a BOO model, build, own, operate. Okay, so the advantage of going for this business model is people no need to spend a capital cost, but they are getting a charger on their premises and they're going to put the charge. So obviously, when some OEM comes and put a charger there at free of cost, and they're going to collect the money from them, it's not going to be the same cost of what they are going to pay for their house. Definitely, it's a commercial. So definitely there will be a slight increase in the cost. But advantage is you cannot buy a 22 kilowatt or 30 kilowatt or 40 kilowatt or 60 kilowatt fast charger from your own packets. You are buying a 25 lakhs car. Are you ready to spend 6 lakh, 7 lakh to buy a rapid charger? You will not. So, but you need to charge the car quickly in 15 to 20 minutes. So how it will happen? Only by means of going through this kind of a semi-public charging models or a fleet operator model. So when you go this, you will have a fast charger in the premises, for which you have not paid for it, but still you can able to use that service for the fast charging, and you can pay the cost for it. So in the process, the OEM or the CPO who install the charger will recover the money over the period of time, and they can able to take their capital invested, and also the users are get benefited of fast charging. So that's a semi-public charging model. And the third is a public charging model where it's open for all users. So it's widely been applied in the places like public parking lots, on-street parking, and there are charging plazas where it's only dedicated for charging of vehicles, and petrol pumps, highways, metro stations, and all these things. People who are in the cities where they have the metro, they can comfortably see the kind of charges which is there. And initially, they given a free charging for the EV cars to accelerate the growth. And now they have charges set at a very reasonable cost. And you have a comfortable parking bay. You go there, park the vehicle, you get it charged, and take it up. So that facility is there. That's all installed by government, owned by government. The money is required. Okay, so the ownership belongs to the municipal authority or the public sector entities or the charge point operators or the host property. Let's say I'm Adani or GMR, I build that airport. If I'm going to install a charger, it's my property, but installed for a public purpose. So similarly, the municipal authority, let's say you're installing in a corporation campus where many government officers come and charge the car. So the capital is invested from the municipal authority for that, whereas the users are the government officers or the officials or bureaucrats or the publics. So most of these kind of public charging stations is not a self-driven or semi-public. It's mostly a CPO, that is charge point operator driven model, because who is going to take the responsibility? Who is going to take the responsibility of managing that station, having the bills to be get assessed, maintaining the billings of the charging, and settling the cost of the capital investment paid for it. So government is not ready to put mind in this subject. So most of these cases, it's CPO based. So CPO means, let's say you consider that I'm a Ola or Uber, and I'm having a model where I will set up the charging stations in the places. Okay, so my business is only to set up a charging station, maintain that charging station, dealing with all the government approvals, making the payment for all the energy which is consumed from the electricity grid, and ensuring the safety of the premises, and also collecting the money from the people who put the charge. So that's a public charging method. So if you see the typical EV charging infra setup with 6 chargers, so government of India, different bodies have mandated or given the guideline for different approaches of installing chargers in their premises. I have given the link of all the bodies and organization, those who have given the guidelines for installing EV chargers at the end of the slide of this presentation. So I will share this presentation anyway. You can have a look at it. So if you see it's a public charging infrastructure, then at least you should have 2 DC fast chargers and 4 AC chargers, and there should be a 4 EV parking bays with 2.5 meter into 5 meter size, and 2 bays for EV cars, 2 bays for EV scooters. So this total setup is collectively called as a EV charging plaza. So the provisional norms for charging points for 4-wheelers, 3-wheelers, 2-wheelers, and even buses. Even people who can see inside the metro cities like Chennai, Bangalore, Hyderabad, you can see the buses which is running in the inside the city is powered by battery. So those are all charged by 240 kilowatt chargers, which means 2 150 kilowatt guns. And there are charging stations built by the OEM itself, either from the bus manufacturer or from the charger manufacturer. So buses will run, and over a period of time, there is a bay where they can park the vehicle, get it charged, and again the bus will come on the road, will drive. So there is a charging pattern cycle. So how the model works here, if you take the case study of Chennai, is the complete vehicle, right from the capital cost of the vehicle, the management cost of the drivers, maintenance cost of the vehicle, everything is calculated at the cost of per kilometer. Okay, so the government is giving at cost per kilometer to the agency who takes that work. So government is not owning any bus, government is not owning any public charging stations, government is not giving salary to the drivers, whereas government is only paying the cost per kilometer to the vendor who is taking up, who is investing this. So this become a little burden free, little capital intense free approach for governments. Okay, so where the entire responsibility is now transferred to the body who is, the entity who is doing all these things. End of the day, he is going to break even at certain point, and he is going to take money out of it. Okay, so that's the thing. And here, as I told already, every 3 square kilometer, we at least should have one fast charger station, and in the highway, definitely at every 25 kilometer, we should have one bigger charging station. So now we'll see the EV charger supported with solar power. So we'll see how this will really works. We all know solar panels can be installed on the rooftops, and it is a clean energy which is coming from the sun, and that's converted into DC, and the DC is again coming to the inverter. The inverter will convert the DC to AC, and the AC is coming for our internal load purpose, which we already seen in the regular applications. Now coming to the point of EV charging station where we can install, it can be installed either for a AC charger application or a DC charger application. So most of the hybrid inverters, especially the European inverters like Fronis, or even I would say the Kako, or the Merson, the many inverters have the facility of EV charging also along with the hybrid inverter. And the advantage is, whatever the power coming from the solar panel, in an on-grid system, it is not stored in a battery, in a grid-tie system. But in a hybrid system or off-grid system, it is essentially stored in a battery. And the inverter will take the power from the battery, and it will convert the DC into AC, and it can charge the car, okay, or charge the vehicle. So there will be a point of question like, what is the purpose of having a battery, charging the battery, again get it charged. So people living in a remote location where they are completely out of grid and they rely only on solar will definitely have a battery backup so that they can charge the vehicle whenever they want. Okay, for that the bigger battery setups really helps. So if you see, if you take a Tata Nexon as an example, so Tata Nexon, it will take to make a full charge, it will take you 25 to 30 units for one full charge. So that is literally 25 kilowatt hour. So 25 kilowatt hour, if you need to have, means you need to have at least a 5 kilowatt hour battery, 5 numbers. So if you have a 5 kilowatt hour battery of 5 numbers installed in a location supported by 5 kilowatt or 6 kilowatt of solar panel, it can generate that much of energy in a day, and that is get charged in the battery. So it's like a charge on the go. So if you have that setup, it can able to support the charging of the car even during the night time. Even if grid is not there, even if sun is not there, still you can able to charge the car with the battery. So that is the advantage of it. On the other front, if you don't want completely a remote, a standalone battery backup system to charge your car, there comes the net metering system. So usually what we do is in a regular conventional practice, from the transformer, it comes to your energy meter at your house. From there, it is connected to a EV charger, and that is connected to the car. So what happened in the system is you are not storing, you are not generating. You are simply consuming the power supply from the grid. So here you can see the existing meter. It is coming to the charger. From there, it is going to your vehicle, either it is a bike or car. So here we are not generating electricity. We are only consuming. So whatever we consume, that is recorded in your meter, that you are going to pay. But when you come to the solar powered EV charging station, the solar panel is going to generate the power and it is going to support. So the present slide is showing the mechanism of how solar can support the EV charging through net metering. So net metering is something which acts like a banking of energy. Banking means you can generate today, either utilize today or export to the grid and adjust it whenever you want. Okay, whenever you consume. So it's like banking of energy. So most of the states in India is having the net metering facility. You can adjust the units. In residential, widely accepted the unit to unit adjustment, whereas in commercial, the cost of energy is accepted in net feeding system. But states like Kerala or some places, they are even accepting for commercial also unit to unit adjustment. Okay. So under the net metering connection, how it works is you have solar panel on the top, and that solar panel is producing DC supply that is coming to the inverter. So that inverter converts DC to AC. So the AC supply is having two possibilities, either to go to a charger or go to the grid or go to the internal loads of the house. Okay. So now the priority is always the DC supply, the AC supply from the inverter goes to the charger. So if the charger is there, it will feed the car. In case the charger is nothing but the load according to the inverter. If there is no utilization for the load here, then the excess power will go to the grid. That's where you can see that bidirectional flow which is mentioned in the grid supply. In case if your load is more, solar panel production is less, whereas the car is also supposed to be get charged, then there will be a possibility of drawing the power from the grid. In case if the production is more, when there is no utilization at the load side, then whatever the excess energy which is produced from the solar panel will get exported to the grid. Okay, so this meter is called as the net meter. This net meter will record how much energy you imported from the grid and also how much energy you have exported to the grid. So the exported energy is subtracted from the imported energy, and that gives the net energy for the billing. Okay. In case, imagine you have generated 100 units and you have consumed 200 units. So the 200, from the 200, the 100 units is subtracted, and only for the 100 units you are supposed to pay the electricity bill. This is called as net metering. So in net metering, most of the places where they use the on-grid system without battery, but when people really want a backup also, they can go with a hybrid system under net metering where you have a battery storage. So the image what you see here is having a battery storage also. So this is a net metering system of solar with battery storage. So that is nothing but a hybrid solar system which is there here. So the advantage is, in case if grid is failed, solar will support. Even if solar is not available, battery will support. Either the battery will support for charging the car. In case if you are not charging the car, the battery will support for your entire house. Okay, but as of now in India, exporting from the battery to the grid during nighttime is not under a practice, because the cost of electricity which you are going to sell and the kind of benefit the government is going to give it to you is very less compared to what are the cost of investment you made for the battery and what are the cost of energy you are going to take out from the battery. Okay, so that's one critical part. Right, now we have seen the solar net metering mechanism, how it works, and how the energy is being transported. So before going into the smart metering methods which is being followed and how it can be implemented, I just want to take few questions about your understanding, how your you know got a better clarity about uh, EV charging stations and the solar net metering. If you have any doubts, definitely you can ask some questions before you go to the few more slides we have to complete. Already we have certain questions on the chat, I think.
So question from Palani Chinna: how to manage traffic in charging stations since it takes at least 30 minutes to charge?
So that is completely based on the user front only, because you need to see in the app. Will you travel, you can, your even the either a OEM or the charge point operators or the fleet operators have their own apps, and even it's linked to the Google. Okay, Google will only show where is the location, but it doesn't show you. Google is also working on it to show whether it is live, active, inactive, like how it really shows the traffic. No, similarly, it is trying to interact with the CPOs to show what is the present status of the chargers. But again, it's a headache for everybody to interconnect or interface all the chargers to be get displayed in the Google platform. So instead, what can be done is all the CPOs and all the OEMs who's having the CMS platform, there are certain platforms which can integrate with other CMS, other OEMs also, which means you have a charger brand, let's say ABB, and that is get installed by a fleet operator kind Xeon. So the same platform in the same app can show the other charger which is being installed by a brand called Okaya and installed by a company called X. Okay. If you can able to see all the chargers in one place and you can see the status of it, it's just kind of an API integration between each and other apps. So there are many companies which is working on mixed class platforms, like how the same theater can be booked in Ticket New and Beginwoods. Book My Show. Okay, districts now. The same scenario, how you can able to reserve a table in a hotel through a dine out, through Swiggy, through Zomato. So similarly, you can able to book a slot for EV charging in multiple apps. Okay, that is possible. So you should follow an app which is compatible for you to park, to freeze your parking space if you really have a plan to reach that location. If not, when you're driving, you should see in the map how many chargers are available in the nearby station, which is occupied, which is not occupied, which is active, which is under offline condition. If you know that it is active and it is free available, you can directly go there and charge it, because all the CMS can able to real-time interact with the devices, and it is all IoT connected. So they know what is the health of the system, what is the present status of the chargers. So through that, you can able to figure it out.
So question from Amit Gupta: can frequent fast charging accelerate battery wear and capacity loss over the time?
Definitely yes, because when you put in a slow charging, always the longevity of the life will be better. When you more frequently use the fast charging, definitely the battery aging will happen faster, at least to the extent of 15% fast.
Any more questions from the participant sides? So I think we'll move on, sir.
Yeah.
Move on.
Can we see the presentation?
Yes, sir. Visible, sir, please.
So the next is the EV smart charging mechanism that you talk about. So the smart charging mechanism is really the same question what the audience have raised. How government know, how the driver will know, how the charge point operator will know what is the real status of all these things. Let's say if 20 EV cars are crossing a toll and if they are going to travel, what is the probability of the cars to be get charged in the next 300 kilometer stretch? So that is one kind of information either a CPO or a DISCOM should have. And the second front, all the vehicles are communicating to the cloud. Okay, all the cars which is now have the smart connect. So the smart connect, one can know what is the status of the battery, whether the seat belts are fastened, or what is the speed at which the car is driving, and what is the fuel level. Everything you can see in the mobile itself. Even it's not necessarily to be an IC engine car. Even not essentially an EV car. Even a petrol car, you can see everything in the mobile. Okay. Similarly, all the EVs, the entire statistics you can see. And the same data is available and accessible for a OEM also. Let's say a Tata app. The Tata is having the enough accessibility to know the number of cars driving in which route and what is the health of the cars. So Tata can definitely able to show and map in the app like what is the nearby charging station, where you can charge, and what is the status of the chargers which is there. And it is very important to communicate the same kind of information to the discoms also. Why? Because let us consider you have a BE60 car which is driving on the road, and that can be able to take 140 kilowatt of fast charger for the charging. And there are 520 kilowatt chargers which is there. And nearby there are multiple charging stations. Imagine after a 300 kilometer stretch, by moment at a time, if 5-6 cars is going to be immediately charged or 10 cars is going to be immediately charged, it is going to consume suddenly 1 megawatt of power from the grid. 1.2 megawatt. Let's say 120 kilowatt into 10 numbers is 1.2 megawatt is going to be suddenly drawn from the grid. So what is the kind of the grid instability, the voltage regulation, which is going to face during the sudden adoption of consumption of the huge power suddenly from the grid without any pre-analysis or pre-intimation. So most of the systems, we used to have a load flow study and energy generation assessment and energy consumption assessment well in advance. So the load flow dispatch center usually have the data about the kind of load shedding is going to happen in some places, the kind of production which is going to happen in the bigger power plants. Even the large size solar plants that needs to give a data about what is the kind of energy yield assessment possibility for the next day. And also if they are planning to shut down also, they need to intimate so that the DISCOM will effectively plan how to manage that shortage of power. If there is a 100 megawatt of plant which is currently running, and if they are planning to shut down the plant for maintenance, if they shut down without any intimation, that 100 megawatt of power, who is going to support? Which is going to make a big big shake in the grid stability. So that is one important point. So the moment when more number of charging is going to happen in the grid network, and the more amount of solar adoption is going to happen in the grid network, the smart charging plays an important role so that it communicate effectively to the DISCOM. it communicate effectively to the OEMs, it communicate effectively to the CPOs, so that they know what is the kind of demand which is presently there, how much kind of demand is going to be get experienced in the over a period of time, and how effectively the grid infrastructure is available. So if this is properly addressed, then we can able to avoid the breakdowns in the future when sudden adoption of EV or sudden charging happens in a short span of time or at the same time. So the architecture of the smart charging falls like the OEM management platform, the CPO management platform, and CPO management platform from the bike side, car side, and the home charging. So if all the chargers and all the charging stations and the CPOs are communicating to the DISCOM, again, effective, the DISCOM is nothing but the TANGEDCO here in Tamil Nadu, or every state have their own distribution companies where they generate and distribute the power to the people's consumers. So if they know these data, they can effectively plan, they can estimate like what is the kind of load increase happen during the weekends, what is the kind of load increase going to happen during the weekdays, and what are the kind of load which we are experiencing only through charging during evening, and what is the kind of charge we are experiencing during the night time. So if these statistics is clearly available with the DISCOM, it is very easy for government to take actions or the planning about improvising the grid network, improvising the existing architecture of the system. And this is the standards and guidelines given by Ministry of Power, Central Electricity Authority, and Ministry of Highways, and BIS and GST. The links are given. You can just download it and have a look at it. You can have enough information to talk about the standards and guidelines of implementing, installing, operating, and maintaining the EV chargers. So now, what are the key benefits of switching to solar charging? So the first idea is to avail the benefits through different metering mechanism, either through the net metering or net feed-in or gross metering. And the main advantage is it is the power from renewable clean power, and approximately 1 kilowatt of solar power plant on an average for a year will produce 5 units per kilowatt per day. So if you have 100 kilowatt, it can able to produce 500 units per day. And 1 kilowatt required maximum of 70 square feet area for a solar panel installation. Nowadays, a single solar panel you can able to get at 650 watts power. Okay, and you can install solar panel in different ways. Like it can even act as a solar car park shed also. Okay, it's not necessarily on a rooftop. It's not necessarily on a ground-mounted installation. You can plan the structure in such a way it will act as a roof for your car parking. Under the panels you can park your car. Under the panels you can park your bike. Under the panels even you can have your restaurant. Okay, it's all the architectural innovation we can bring in. And the metrics of solar is mainly depends on the different models. Like as I already told, individual, custom driven, government, semi-government, service providers. So the idea is to distribute the EV charging infrastructure across the locations of the country, and have to effectively manage the EV charging loads, and have to implement the smart charging mechanisms at all the possible nodes of the EV setup, and also can be worked as a business model for the investors or individual who really looking to get into this business. So to conclude, be inspired. Imagination is more important than knowledge. So of course the industry is so big, the opportunities are so large lying in front of you. How we are going to take this as an opportunity for us on the everyone's angle. Let's say for a student angle, how I can able to do projects on that. For a research perspective, you can see like we have addressed many points during this presentation. So you can identify what are the problem statements that you can able to identify. What are the key areas where people face bigger issues? So mainly it depends on the grid reliability, grid resilience, and safety of the systems, and the power quality issues, and the kind of harmonics get developed because of implementing different chargers, and the kind of behavior of using the chargers during the peak time, non-peak hours, under different frequencies. everything needs to be analyzed, and we need to understand how the grid will behave when more number of charges is going to be get adopted, and what are the kind of impact difference between having a fast AC charger and fast DC charger, and also based on the nature of vehicles also. Okay, so this I conclude the session with line. Future is based on the three setups. One is the solar, other is the EV, other is the battery systems, and other is the green hydrogen. If we are going to effectively integrate all these things into your infrastructure, it is going to make a big difference, and it is going to have a bigger opportunity in each and every area and every individual's either a career or business. It's really a bigger area to work on it. So thank you very much, and this is my contact details. You can have a note about my number and email ID. In any case, in future, if you want, you can definitely reach out. You can WhatsApp me or you can mail me. I can definitely support you. Thank you very much. If you have any still questions, you can definitely drop in the chat. I can answer you.
Sir, one question from Jinka Sriranga Naikalu. What kind of career opportunities are there in EV technology?
EV technology.
Yes.
You can be a charge point operator, or you can do the trading of chargers. You can be an EPC, an engineering procurement, installer of EV charger, or you can even design act as a consultant for bigger organization to put or install these things. Even you can act as a licensor to get the approvals for installing EV, because whenever you want to install a EV charger, you need to increase your load. If you don't have a load, you need to increase the load. So that licensing is also one bigger important. It's based on what is the profile of the audience who is looking for a career opportunity. If he is a graduate, there is some set of job roles which is available. If he is a technician, there is a set of opportunity available. If he is a businessman already into the business, then he can look some other opportunity. But definitely it is there. But I would say the EV is in the phase of like 10-15% of the maturity market compared to the solar of 60%. Okay. Still solar have another 40% to reach its 100% maturity, whereas EV is having 80% to 90% to see its maturity.
Hope the participant got the answer. If any other participant is having any queries or questions, please let us know. You can unmute your mic and ask, otherwise you can put your questions in the chat box. Any queries or questions from the participant side? Otherwise, you can wind up the session.
Sir, good evening. This is Raghunathan from Mohan Babu University. I have a question, like just a clarification. What may be the entire setup weight to the overall vehicle, sir, in terms of percentage of entire vehicle weight, or separate EV enclosure? What may be the weight of that?
What weight of battery you're asking, or solar?
No, sir, battery means entire panel, battery, total battery enclosure, sir, for EV vehicle.
That is actually weighting almost, I would say, 35% vehicle weight. 35 to 40% vehicle weight is battery.
Oh, 35 to 40% means almost, for example, if 1 ton means almost 500, nearly 400 to 500 kg will come, right?
That's based on the kind of vehicle what you're talking about. You're talking about a car or a bus, or what it is?
Sir, car. We will take cars, sir. So, for example, any EV cars, any sedan type car.
See, the thought, if you see a 5 kilowatt hour battery, if you see one battery,
okay,
it will weigh you almost 5 to 7 kg based on the manufacturer. Okay. Even if you see much more a better thing, it will go up to 10 kg. for a 5 kilowatt. If you have a let's say 50 units, 50 kilowatt hour battery, then you need to have 10 batteries. Okay, so it will be at least 100 to 150 kg of the battery for a vehicle of, let's say, 900 kg or 800 kg, a small vehicle, if you see.
Okay.
So that will be based on what is the nature of car. Let's say if it's a small Tiago, the form factor is very less. If you go a bigger SUV or a bigger cars, the battery capacity will be more. Not only the battery, the kind of other onboard chargers, battery shielding mechanisms, enclosures, everything will come into the picture.
Okay, sir.
If
Thank
it
you.
is,
Thank
if
you.
it's NMC based, it is NMC based. But the recent technology like lithium polymer and the glass electrolyte batteries, obviously the energy density is more, so the weight is becoming less now.
Okay. So then, compared to solar panel, how it will be comparable? Is it comparable, or definitely EV is a separate segment? We can have.
See, solar and these is like a brothers and sisters. Okay, it can be same, but it can work together. If you install a solar in the premises of EV, it makes your viability much better. That's all.
This,
Raghunath sir, hope you got the answer.
yes, sir. Thank you. Thank you.
Any other questions from the participant sides? There any other questions, queries?
One question, sir. One doubt.
Yeah.
Hello. Sir, I'm
Please, sir.
Premnath
Please,
from
please.
SRM IST, sir. So regarding the solar installations in the household or domestic application, there is no, when we are exporting the power to the grid, is there any charges they are giving, government is giving to us? As per your presentation, there is no charges being given to the customer as we install 1 kilowatt or 10 kilowatt something.
See,
solar
that differs from state to state. See, since I'm from Tamil Nadu, okay, so in Tamil Nadu we have a concept called network charges. Okay, network charges. So network.
இது ATAL FDP solar EV panel பத்திங்க question கேட்டுட்டு இருந்தா பேசு.
Hello.
Sir, please, sir. Please continue.
Continue, sir.
Someone trying to ask the question or what?
Yeah, some disturbance, sir. Now it's clear, sir. Please, sir.
Okay.
You can answer Mr. Premnath, sir.
So,
Yes, sir.
policy, the energy policy varies from state to state. Let's say I'm from Tamil Nadu, so I'll give a brief about how things works here. Okay, so here in Tamil Nadu there are two things. One is the cost of energy which a customer is supposed to pay. That differs for a LT customer, HT consumer, domestic consumer, commercial consumer, industrial consumer, educational institutions, temporary connections. So multiple categories. Now for residential consumers who fall under LA1A tariff category, people can able to adjust unit to unit. That means 10 units exported, adjusted in the import of 10 units further. But there will be an additional cost called network charges, which has been applied over the generation of every units, not on the export, against the generation of every units. Consider your plant is generated 100 units this month. So 100 units into 30 paisa per unit, which means 30 rupees is added in your bill as a network charges, which you're supposed to pay. And there will be a question comes into the picture, why I need to pay this network charges? Because your on-grid inverter will only work when a grid is available. So in order, since you are interacting with the grid, you are exporting to the grid and adjusting in the future bill, you are actually reducing the revenue which is going to the electricity board. So since you are taking the reference of the grid to make your system to work, government is putting an additional charge called network charges, which is indirectly meaning that you are utilizing the grid infrastructure of DISCOM to bring all the way the power to your house to make your system to work. That's what it is called as network charges. That is for domestic category. Coming to the commercial category, the network charges is 1.6 rupees per units for generation of every units. Okay. So that is defined by the State Electricity Regulatory Commission and the DISCOM of every state. So according to the state's policy and state regulation, it varies from state to state, but most of the states are having their own network charges, own fixed charges, own net metering policies. So one must have to follow the rules. According to Tamil Nadu, this is the rule.
Fine, sir. Fine, sir. Fine, sir.
Okay, Rajaganesan sir, thank you for your valuable time with us.
Yeah.
And it's a session more or like interaction among you and our participants. Hope a number of participants have got benefited through their questions and all. And we are having a great insight about the EV, the charging, the infrastructure and all. Thank you so much for your valuable time with us. On behalf of the Department of Mechanical Engineering, Adishankara Deemed University, once again we thank you for accepting our invitation and spending your valuable time with us, sir. Thank you so much, sir.
Sure. Thank you very much. I also thank you for giving this opportunity to meet all the professors in same place. And I would always like to interact with the academicians more, because I feel that's a great opportunity for interact with the people who really creating the engineers for future world. And we as a company always trying to act as a bridge between the industry and academia. So that the problem with the present scenario is there is a big gap between the industry and academia. That's why people find very difficult when they come out of the college, finding very difficult to get placed in a core company and end up in entering into an IT field and end up in doing some field which is completely irrelevant to what they studied for the last 4 years or 3 years. So that's where the focus, even if you see the guideline of UGC now, ACT is all focusing towards engaging industry a lot. That's where many programs are targeted. Even the internships and in-plant training visits are even mandated for the faculties to go during the semesters. So to get more interaction with the thing. And the practice of internship is also one important factor now for the students, that act as one of the credit rating mechanism for them, and implementing the industry-based electives in the curriculum, adopting the industry peoples on board as a advisory member in the curriculum for autonomous institutions. All this really matters a lot to align the curriculum in line with the industry requirement. So
certainly, sir. Certainly, whatever you are saying is exactly right. And now we are around 100 people are here, and we have a contact with you. Definitely, we'll be get back to you for all the aspects what you have told regarding the advisory board. Everything we will be in touch with you, sir. Even from Adishankara University, we will be in touch with you for future programs and future activities and all, sir.
Sure. I think people are asking my contacts. I already presented a thing. Anyway, I got
yes, sir.
Yes. Yeah. So they can have, and I would love to see the kind of feedback what they given. That's my practice.
Definitely, I will share the feedback. Whatever I have received from them, I will share with you, sir.
Yeah. Thank you very much. Thank you, participants, for their patience, presence here, and also a lovely interaction. It's good that you interacted and put a lot of questions. And it also made me more driven towards giving more details to you. Thank you. Thank you all. Have a nice dinner and have a good night.
We have another session also, sir.
Oh, sorry. I missed you early. Let me go for a dinner, and you all enjoy after hour. Thank you.
Thank you, sir.
Thank you. Bye.